Okay, another problem finding a maximum of a function. This one's dealing with farming. It's number 40 in the book. They say a strawberry farmer will receive $30 per bushel of strawberries during the first week of harvesting. Each week after that, the value will drop 80 cents per bushel. Okay. The farmer estimates that there are approximately 120 bushels of strawberries in the fields, and that the crop will increase at a rate of 4 bushels per week. Okay. And they say, when should the farmer harvest the strawberries to maximize their value? Okay, so here's the situation. We've got a farmer who is facing two kind of competing concerns. On one hand, by waiting, the price of the strawberries is going to go down. But on the other hand, by waiting, the amount of strawberries in their field is going to go up. So the question is, how long should this farmer wait in order to get the maximum value from harvesting the crop? So this is a problem where, in some ways, it's not too difficult, but there's a lot of stuff we have to kind of develop to get set up and ready to go. What we're trying to maximize, I'll call V. It's the value of the crop. Okay, now in this case, value, and in farming, it's a very straightforward situation. The amount of money the farmer is going to bring in is the product of two things. Now I'm just going to put big parentheses here and say what those two things are. It's the price per bushel, okay, times the number of bushels. Okay. So if the farmer knows something about each of these two things, the price they're getting per bushel of the crop, and they can just multiply by the number of bushels they're going to harvest, and they'll have the total value of the crop. Okay. Now what's difficult in this problem is to figure out what goes into these two things, because there really isn't a variable, and that's where we have to really use some insight, and really more than anything just some practice and familiarity of good choices. But everything that they tell us in this problem depends on time. So they kind of give us a starting date, and then they tell us, if you wait a certain amount of time, certain number of weeks, here's how things change. So we need a variable here, and I'm going to pick the variable x to be the number of weeks the farmer waits. Okay. So at this initial point in time, they've given us some information. We'll call that x equals 0. Okay, now if the farmer waits 1 week, x would be 1. If he or she waited 2 weeks, x would be 2, and so forth. So the number of weeks the farmer waits to harvest, let's say. Okay, so what about the price per bushel? Well, what do they tell us about that? They say $30 per bushel of strawberries, okay, but for each week the farmer waits, the value is going to drop 80 cents per bushel. Okay, so the price per bushel is 30, okay, minus 80 cents times x. For each week we wait, we have to subtract 80 cents from the price we're getting. Okay, so that's the formula, and that's something you just have to kind of put together using the algebra of the describing the problem. Okay, so number of bushels. Well, again, they say right now the farmer estimates there are 120 bushels of strawberries in the field, and that the crop is increasing at a rate of 4 bushels per week. So right now, at the beginning of time, when we start this, there are 120 bushels, but for each week we wait, we're going to add 4 bushels to that. So if x was 0, we don't wait at all, we just have 120. But if we waited 1 week, we would have to add 4 bushels to that. If we waited 2 weeks, we'd have to add 8 bushels. So we want to add 4x to this formula. So this will give us the number of bushels incorporating the amount of time we wait. Okay, so what happens here? Well, now we need to kind of deal with the function. We've got a function. We want to figure out what value of x maximizes this function. So the value of the crop is given as a product. Probably should go ahead and multiply these things together and simplify the function a little bit. 30 times 120, that's 3,600. So I'm just foiling these together. Let's see, 120 times 0.8, so it's going to be negative 96x. Foil these together, it's 120x. Okay, and then the last terms will be negative 3.2x squared. Okay, so the value of the crop is 3,600. It's going to be plus 24x minus 3.2x squared. Okay.